Look at this poorly animated cube. Nicely colored, spinning, seemingly nothing special. The sprite looks something like this, a long picture with all the frames on it. Now, let's step into this area. As you can see, the sprite has changed, but seemingly nothing out of ordinary has happened. Under the hood, however, the new sprite was not made by me, but a script. This texture looks like it was made for 3D objects. With this solution, it's easy to create a lot of textures for my cube, without having to touch the animation. Let's see how. If you're curious to see how I use this and similar crazy ideas, check out our devlog videos. If you're making a classic 2D pixel art game where you need a lot of sprites that only differ in color, then this is a good solution for you. For example, if you want a variety of NPCs, or your main character can wear different clothes. I would like to point out that the idea is not mine. You can watch the original video that inspired me here. The creator of this video works in Unity, but the theory can be implemented in any engine. Let's see how to do it in Godot. We need 3 images. A base, where you create the animation, a mask, where you fix the location of the colors in a coordinate system, and a skin, where you assign colors to the mask. The base is like the classic sprites you would use. It contains the animation divided into frames. The hard part begins when you start coloring it. Color the first frame so that each pixel has a different color. You can use some scheme to do this. For example, your character's left leg gets shades of green. His right leg gets shades of purple. On the other frames, continue coloring so that the colors always represent the same parts of the character. For example, if his knee is a cyan color pixel in the first frame, then his knee should be the exact same color in the other frames. Once you have the base and the colors are in the right place, you need to make the mask. This is an image with all the colors on the base. This will be easier if you try to make it look like a texture of a 3D model, so the close pixels of the base are close together here too. Finally, the skin needs to be created. This is done by copying the mask, then recoloring each pixel with the color you originally wanted to be. Now that we have 3 images, we can make the script that does the magic. Let's make a sprite 2D node, and then a script for it. Create 2 export variables, the mask and the skin. Both should be resource types. We will store the extra images corresponding to their names in them. For transparency, we will create 2 other variables, mask.img and skin.img, which will have a value of null, and the animation.img variable, which will have the copy of the current texture of the node. In the ready function, the first 2 img variables are given the values of the resource variables converted to images. Let's create the getNewColor function, which takes a pixel from the base as a parameter, and returns the pixel that contains the matching color of the skin. To do this, we simply iterate over the mask as a matrix, and then check which pixel of the mask is the same color as the parameter pixel. If match is found, we return the pixel of the skin image, whose coordinate matches the current pixel in the mask. If no matching pixel is found, return a completely transparent pixel. Finally, create the changeColor function, which copies and then iterates through the animation.img image, also in matrix style, and calls getNewColor for each pixel. Copying is important so that the function can be run multiple times in case we need more textures. Without copying, they would all try to transform the same image, which would cause problems. After the first transformation, it would not find any color because the base has been recolored. After the scan, we get the new texture, which can be now managed with a variable. If you want, you can change the base immediately, or you can even delay the change. From here, it's up to your imagination. As you can see, the code is just a couple of loops and color swaps, nothing difficult. Once you understand the theory, you can easily make use of it. It's a very useful way to avoid repetitive sprites, and in most cases it speeds up your work a lot. I hope I've been able to help you make your game's graphic much more diverse, with much less work.